going to do like we did last time, where we'll go through each one. Oh, a packet. Can you just write them on a sheet of paper? And yeah. So let's review what we said the other day. I'll write out the steps, and then you can. So the first thing you're going to do is you're going to choose U, which in this case U is equal to is equal to 4 minus x squared. Now I could just multiply this out and take the integral, but let's just go ahead and do it using the u substitution. So I'm going to let u equal the term in the parentheses, and the second thing you do is you calculate du. Then you, the third step in this case, because it's a definite integral, is change limits. So you'll say when x equals 0, u equals something. And when x equals 1, u equals something based on what you've chosen here. Then once you do that, you'll substitute your substitutions here, and substitute and make integral function of u. The difference in this case is when you integrate it. So let me just add a page here. So the difference is when you integrate it, step number 5 is you evaluate the integral using the u limits. You don't substitute back in. So once you get the result here, you'll end up with something with a vertical line with the limits u equals something to u equals something, and then you just evaluate it at the upper limit. And the upper limit is not always the most positive number. In this case, you'll find out that this number is actually smaller than that number, but it doesn't matter. You can just do it the normal way. This is the upper limit. It's not necessarily the most positive number. It's just the one that's up here. This is the bottom limit, lower limit, because it's down here. Okay, so don't get confused when you get to that part. If you have any questions, need help.
So what exactly do I do next?
Okay, so you've got du. Don't forget your dx. So it's minus 2x dx. Okay, now what you do now is you substitute in. So for 0, you're going to put in u equals 4 minus 0, which is, so when x equals 0, u equals 4, which is what that is, okay? And when x equals 1, u equals 3. Okay, so those are your new limits. So you're going to integrate from 4 to 3. For 2x dx, you're going to substitute in du. Actually, negative du. So you're going to have to solve this. You've got 2x dx here. So you really need to divide both sides by negative 1. So for this, you'll put in negative du. And this part, you'll replace that with u. And then once you got that, then you integrate just like you normally would.
And you said replace dx with u?
Yeah, you're going to replace 2x dx with u.
Okay.
Or actually with negative u because of the negative sign here. Okay. Yeah, so remember that you're going to have du here is going to be equal to negative 2x dx. You're replacing 2x dx, not negative 2x dx. So when you make the substitution here, you're going to say 2x dx equals negative du. So this will be replaced with negative du, and this will be replaced with u. And your limits will be, so u in this case is going to be 4 minus 0 squared, which is 4, and this limit is going to be 4 minus 1 squared, which is 3. So when you make the substitution, the integral you'll end up with is the integral from 4 to 3 of u times negative du. So for this I put in u, and for 2x dx I put in negative du. Notice the limits, as I said, this one's smaller than that, but it doesn't matter. There's two ways you can handle it. You can just handle it normally, or one of the properties of integrals is if I change the limits and I add a negative sign in there. So what I've done is I've changed the sign here to positive, and so if you flip your limits, you just have to change the sign of the previous integral. Obviously that's easier, but go ahead and do it that way. I'll do it this way, you do it that way. We'll show we get the same answer. I mean, all you're doing when you change the limits from the upper to lower and lower to uppers, you're subtracting one. You're just changing the order of subtraction, so it's not surprising that that's the rule. Okay, so there's your answer. So I factored out the negative sign. So I had the integral of u du. So that's just a polynomial. So you add 1 to the exponent, divide by the new exponent, bring your negative sign down. When you do the integration, you drop the du and replace it with this vertical line and substitute the lower limit and the upper limit. At that point, the next part is to substitute in the upper limit and subtract substituting in the lower limit, and then the rest of it is just algebra. So you get 9 halves minus 16 halves, which is negative 7 halves, times negative gives you positive 7 halves. Okay, so that's the procedure. So here's another one. And I'm gonna hand something out while you're working on that. Another in-class assignment, if I can figure out where the heck I stuck them. There. Oh, actually, I did have some extra ones here. Who needed? Daniel needed one, right? Sorry. I'm more efficient than I thought I was. While I'm up here, let me hand those out. Yeah, so remember to convert your square root to a fractional exponent and then move it to the numerator. Also, your du will have a 2 in it, but your substitution doesn't have a 2, so make sure you divide the divide du by 2 to get it in the form for substituting correctly. So this handout is the other type of u substitution that we talked about at the end of class last time. So once we finish this one, we'll do these. So I got 1/2 for my answer. So again, you pick u in the argument of the square root. Du becomes the derivative of this, which is 2w times dw. I have w dw in the expression, so I solve for that. So I divide both sides by 2. So I have these. I'm going to make this substitution here. I'm going to make this substitution for those two. My limits, x limits, were from 0 to the square root of 3, but u is w squared plus 1, so actually that's w, sorry. So w, so you get 0 squared plus 1 is 1, and then if you take the square root of 3, square root of 3 squared is 3, plus 1 is 4. So you make this substitution d over 2, this substitution u, change the limits from 1 to 4. Before I integrated, I pulled the fraction out, changed 1 over the square root of u to the u to the minus 1/2 power. Then I used the power rule for integration, so I added 1 to the exponent, and I forgot to do something. Divide by 1/2, sorry. So this is so this actually cancels out because you've got 2 times 1/2, so that goes there. So the actual answer is 1. Okay, luckily I went through it again. The answer is 1, not 1/2. Okay. Okay, so I'll give you time to start in the next one while you're absorbing the last one. It actually ends up being the same integral once we make the substitutions, except you're going to have you'll have a different factor instead of 2 like we did over here. the 1/2 thing will have probably a third, I think. Oh, you're still, oh, you're getting ready.
Yep.
You're storing up brain power for, oh, you're over here. Let me see what you got here. Okay, so there's little things like, don't forget your equal sign. And also don't forget your dv. Yeah, yeah, okay. So what you've got here is v squared plus 1. Here you've got 3v squared plus 3. So you can factor out a 3 to get it so that it does match up. 3v squared plus 1, yeah. Then that matches up with the numerator. So then you can divide by 3 and then make sure you either mark that out or divide it out, because right now you haven't completed it. Okay, now you need to change your limits. So evaluate your limits. Okay, so be careful, you've got a plus sign here. So when you take the derivative of this, you got 3v, oh wait, you do have plus sign, okay. When you factor out the 3, you should be left with, see, the dv is multiplied by the whole thing. So what you'll end up with is v squared plus 1, the whole thing times dv. Okay. Let me see what you got here.
I think I'm missing somewhere.
No, it's, well, yeah, sometimes it's not messing up, it's just, there's a little, so you're correct, but I'm going to, just to be, you put the parentheses here, I would still keep the parentheses there, because if you don't, you'd think it was 3v squared plus 3 dv, just 3 times dv.
Yeah.
Okay, but you reflected it over there, so that's fine. And otherwise, you're fine. Yeah. So what I'm going around now is I'm looking for just subtle little things like where you should have a parenthesis to be more correct, and also just when you're doing things, when you're dropping DVs, and when, you know, a lot of people tend to keep the DV in there or the DU in there longer than they should. So just want to make sure that it all looks good. Okay. Let's see where you are. Okay. Okay, so that's right. Now you have to remember your DV. So put the parenthesis around the whole thing so that you know that you're multiplying everything times DV. Okay. So did you same thing here? You got to put a DV at the end of that. So put parentheses around that, and then put a DV at the end, and then the DV should be right there, because you've got a DV here. So to make the substitution, you've got to have DV as part of that to be exact. I mean, a lot of people still get the problem right, but they're just, yeah, it's just little picky things that I'm being more picky about this year. I'm trying to see what you're doing in your little, let me see what you got here. Yeah, so let me, you want to put parentheses here so that you know that this whole thing is times dv. I mean, I know you're doing it right up here, but it's just, yeah, I'm going to personally come around to everybody because everybody's doing the same thing. You got to make sure you put parentheses here so that it's clear that that's multiplied by dv. Otherwise, you don't know that.
Okay, yeah.
I mean, it have to be correct, but so let's see if you've done it right here. So, okay, you're using x, which is fine. Yeah. Yeah, so that's good. Okay. I don't want anybody coming back and saying, I took another calculus class and my professor got on me for these little subtle things that don't necessarily stop you from getting the right answer, but are not quite right. So. So don't forget your parentheses there. Now, up here, you'll say, well, you don't do it up here. And the reason you don't do it up here is because this is the numerator, and so it's obvious that these things are grouped together. But when they're not in a numerator and this is separate, then, see, this dv being down here says it's dv applied to this whole thing. So that's why you don't need parentheses there, but you do need parentheses here. I keep doing. Oh, no, that's right. I was thinking about last time I messed it up, almost double messed it up here. Okay. Anybody get my answer? Okay, good. Anybody got any questions about what I did? Just some procedural stuff here. Usually, here, of course, I have to change this to a fractional exponent, and I always factor out this constant that you end up getting if you have something other than the exact matchup as far as the numbers are concerned. So I always factor that out because I want to get this into an exact form that I could say this is the formula in the book that applies to that. So I add 1 to the exponent, divide by the new exponent. I took the reciprocal of 1/2, which is 2, so I took 2 times 1/3 gives me 2/3. And then I changed u to the 1/2 back to the square root of u. Okay, so on we go. Here's the next one. What time do we have here? 8:44. Okay. Now you can integrate it. That's u. U is 3x plus 1. Anybody got to get that for the answer? Yep. Okay, good. So I'll leave that up for a second. If anybody has any questions they want to ask me about what they did wrong or what I did. Actually, I'll start on this side now. Okay, let me just look at the way you've written this. Hungry. So the last problem, this 9x squared plus 6x plus 1, is 3x plus 1 quantity squared. So when you make that substitution, you can solve the problem. So go ahead and see what you get. Anybody got that answer? Okay. I ended up doing it as a fraction because there weren't any square roots or powers or stuff. But u is 3x plus 1. du is, so the derivative of x is 1. So you get 3 times 1. You add the dx. The original equation had dx in it, so I solved for dx out of this one. Also, then I found change the limits, so when x equals 1, you get 3 times 1, which is 3 plus 1. 3 plus 1 is 4, and when x equals 2, you get 6 plus 1, which is 7. So those were my new limits, 4 to 7, 1 over u squared times du over 3. So I factored out the third. I rewrote 1 over u squared as u to the minus 2 power. So I added 1 to the exponent divided by the new exponent. Factored out the negative sign, changed u to the minus 1 to 1 over u, plugged in my upper limit, subtracted, plugging in my lower limit, and the rest of it was algebra. So you guys can turn that in. Tomorrow we'll do the handout I gave you today, and we'll talk about section 6. And so we'll be done with chapter 4 tomorrow. The next test is next Thursday.